just sending it out to all. Welcome all the faces I haven't met, because people exist only with faces right now. Well, and a little bit of shoulders.
In your case, Tanya, it's always more than one face that we get to look at.
True. So and today this is the face of Paola Villarreal, doing a Mexican-born computer scientist who also worked for many years coordinating women who code in Texas, and did a lot of other, but ended up in industry, and it was called out by MIT Review is one of the 35 under 35 innovative researchers. And among other things, what I love is also that her data analysis and visualization work helped reverse the discrimination of more than 20,000 fraudulent convictions by showing the correlation with convictions and demographics of the neighborhood where those convictions happened. So, yeah.
Well, shall we get going?
Yeah.
All right, welcome to the 2021 Translational Data Analytics Computational Social Science Community of Practice Research Short and Sweet. It is quite a mouthful, quite a title. This event is designed to give people interested in computational social sciences an opportunity to see the kinds of work that's being done in this area right here at Ohio State University. Before I get started today, I just wanted to acknowledge and express my thanks to Dev Singer for her help putting the slides together today and putting the event today, and of course to Bear Braumiller, who is leading the community of practice this year, and actually every year up until this point. I think it was he was there at the birth of it. So today, each presenter has sent in 3 slides, and Deb has assembled these all into a slide deck, which she's going to run for us from her computer. This will be fun, this will be exciting, interesting, catastrophe prone, because these are lightning talks. We've set the slide deck to auto advance. Each presenter is going to have 3 minutes, and there should be a 15-second transition slide between presenters to allow us to shift speakers. However, I will say, because we're presenting this from, or Dev's presenting this from her computer, you should just be able to start speaking. So you shouldn't have to do anything to Zoom. So just jump in, and if you hit your time limit with good humor, please just stop mid-sentence and allow the next presenter to pick up. That's part of the fun of lightning talks, isn't it? Of course, we also want this to be as interactive as possible with this crazy format, and to allow new research collaborations. That's really one of the main goals of this event. And so we encourage everybody to post questions for the presenters or comments into the Zoom chat, and we're going to curate the Zoom chat as best as we can throughout, and I'll certainly save off the transcript afterwards, and we're going to follow up with an email with any information. So if you have papers or links that you want to post in the Zoom chat as we go forwards. The agenda today is this introduction, these logistics that I'm going through. We'll get into the lightning talks here in a moment. I think we have 11 presenters, and that's going to hopefully leave some time for a moderated question and answer period afterwards, a brief discussion, and then we'll wrap up. So hopefully we can get through this in an hour. Dev, did I miss anything?
I don't think so. I just want to shout out to the presenters. If at any time you want me to manually advance or go back a slide for you, just let me know and I will make that happen. Otherwise, the slide deck is created for 1 minute per slide and a 15-second transition slide, just like Sean said. That's it.
And I would, sorry, ask everyone who's not speaking to mute, to remember to mute themselves.
Yeah, good point. And do we, Dev, do we have a list of speakers in a text file that we could easily paste into the chat?
Absolutely. I'll do that once we get started.
Okay, thanks. Well, who's first up? Do you know offhand?
Silvia is first up, I believe.
Okay. All right. I think that they're in the order that I had them in the email for the presenters. So until we get the list of presenters posted in the chat, if you can remember where you fell, then you'll have some idea. So with that, let's get started.
Yes, ma'am.
Hi, Danielle. How are you today?
I'm
Great. Can you mute? Hey, Sean, you're the host. Can you mute everybody who's not speaking?
I can try. I'm not sure. I don't know where that feature is, Tanya, I have to say.
You just go to the list of the participants and you have the power to mute them.
Okay, I will do that.
All right. I think I'll just get this rolling. It's my honor to.
Oops.
I just unmuted myself. I hope that's okay. You are muted. I'm being shown that I'm muted. Can you guys hear me?
We can hear you, Sylvia. Sorry,
Oh, okay.
I was muting everybody, and I didn't have a mute everybody but Sylvia button.
You need to add that. So let me get started here. So my background field is communication science. I am, however, very interdisciplinary in my interest, and the focus of my research is the selection of messages, typically in digital environments, and that is then connected to computer science, psychology, sociology, and so forth. And the content that I might be studying could be the filter bubble, echo chambers, like why we might avoid vaccine information. Wow, this is fast. Can you go back, Dev, please? Dev? Yeah, thank you. And to the next slide, please. So let me highlight a few things about my work. So I see my work as complementing other areas in big data science. Like you can find a lot of trace data, how people select what they engage with online. I complement that big data message selection work through custom-made experimental software that tracks specifically what people view in an experimental website. So my environments are carefully designed, like the one that you just saw there briefly, to create carefully designed experiments where maybe one particular aspect, like the avatars that you see, or how many likes a message received, that is then carefully manipulated. And here's an example where you might have picked out climate change as a topic, and then you might see messages that are associated with, let's say, African American avatars and white avatars, and you might prefer to see messages from an in-group member. And I can carefully then analyze what are the driving factors that attract you to a particular message, how much time you spend there. And that can be done in a social media context, in an online news context, on a mobile device with search engines. When you think about it, there's so many different contexts where we select messages that then affect our perceptions of the real world, what behaviors we engage in. So the whole notion of what we consume in terms of political messages, what health messages we consume, what environmental messages, or how we pick out career information. Across all these content domains, I'm interested in what makes people consume a particular message, like source cues, popularity cues. All these could be factors that influence your message consumption. And I'm also then interested in how people then change their behaviors and perceptions. Bam! There we go. Thank you for your attention.
Hello, everyone. So for the next presentation, we'll be proposing a model for jointly analyzing social network and attributes information. So the example that we're using today is a French-Elise data set. So in France, it is known that old school ties has a strong hold on your career trajectory and your status later in life. So the photo that we're showing here is the graduation picture of the class of 1980s of the École Nationale Administration, one of the 3 prestigious schools in France. So the 3 red circles associated with the candidates for presidential election in 2012. So graduates of this class and of this school has a strong hold on the French society, is strongly influenced with their political careers in the future. So using this data set, we'll try to look at the association between the social network and their education, political affiliation, and their career trajectory. So this is a result from our joint living space model. So we're able to find each location for each elite and their attributes information. And based on this graph, we're able to find the division within the circle, the French elite circle. On the box plots on the right here, we see high internal connectivity and low between cluster connectivity. We also find that in the left moiety, we find high education background, ENA attributes, polytechnique, prestigious schools, and cabinet members, inspection general de France, and also being a socialist or a centrist. On the right cluster, we find being a capitalist and also coming from a high class background. So the division between the left and the right are previously known, and based on our model, we're still able to find a further division within the left moiety. We're able to find that a third cluster in this joint linear space, as shown on the box plots on the right here. Each of the clusters are defined and labeled by their key attributes and colored differently. So high internal connectivity and low between cluster connectivity. We're able to find that Polytechnique, which is an engineering focused prestigious school, indicates an alternative career path for the French elites. These elites usually end up in technical ministries compared to being political appointees. So the divisions in the political affiliation, education, and career define the division.
Okay, thank you. I'm John Gray. I'm at the Fisher College of Business. I'm a professor there, and my overarching research interest is studying hard to measure and hidden risks and challenges in global sourcing decisions. And where I've really focused a lot is in the drug supply chains. And I've worked on some policy implications, et cetera, with that. And really looking at quality risk and now a little bit on shortage risk as well. So one area where there's a struggle is how to even measure quality risk in supply chains. I list various ways that we've done it, but I think there might be some smarter ways using better computational social science techniques. And then even how to measure shortages and how to even define shortages. I have looked at many key factors driving quality risk based on supply chain decisions. And this is my usual approach is causal inference, trying to use econometric methods to look at some of the factors like I list below. I have not yet gotten into really good predictive models, really where we can give the FDA, and I'm on contract with the FDA, I should mention, we can give the FDA kind of probabilities and risks of quality risk in the future or shortage risk in the future. And so perhaps some machine learning methods might be possible. I made this a 2-minute slide, and actually I went ahead. Yeah, let me add a little bit to this. So the drug supply chain resilience is a big push with the Biden administration, and some of this research in these areas we're attempting to help with the policies such as reshoring, better transparency, things like that we can use to try to reduce the likelihood of drug shortages and or bad quality drugs making their way into the supply chain. So that is that one. And then I got one more minute right here. Okay, so a couple other areas that involve some kind of potential computational social science approaches. Through a PhD student, looked at confidentiality risk in global software development. So really similar questions. Instead of quality risk or shortage risk, we're looking at the loss of intellectual property when you outsource and or offshore the development of software. We use video games and look at games that were breached versus games that were not, and have tested various location-related factors and firm-related factors on how they relate to the likelihood of intellectual property loss. It's a really hot area, obviously, and there's other industries, not just video games, that do a lot of global sourcing of software development. Two other big data sets. One is, well, one's big data, one's not. Drivers of employee safety performance. I've got one paper and looking at some other areas. We did find, unfortunately, more debilitating injuries led to longer organizational survival, not what we had hoped. And then looking at decision making in sourcing. So thank you.
Janet, you are muted.
Thank you. Time, place, scope, a journey through the Supreme Court. And I believe Enan might be on now. This project would not have been possible without a whole team of BDA undergrads. So really excited about some of the data visualizations you see here. What we're running through is where Supreme Court cases originate from by topic and by decade. So we have a lot of data here. It's an exploratory analysis of the density of cases and interest groups to try to look at geographic origin, the issue of the case, and then over time, because the idea in the court's literature is it should be random, right? There shouldn't be any more probability of a particular case coming from a particular state. But there's a lot of anecdotal evidence and really only a couple published papers that says that's probably not the case. So here you can see some high heterogeneity based on issue areas. This slide is really cool because it goes from after World War II to current. And if you look at the bottom half of the graph, you'll see a huge increase of interest group participation in cases. And so what we're doing is we're looking at if it isn't randomly distributed, is it proportional to population? Does that explain where the concentration of cases are coming at from the Supreme Court? Perhaps it's related to where there's judicially active interest groups, which you can see a bit here at the bottom, or perhaps it's the issue area of the case. And we explore all of these in the exploratory analysis and gotten a really enthusiastic response from judicial politics scholars. And you can break it down by the issue area here as well. So for example, if you just look at the most recent column there, there's a lot more civil rights interest groups than there are cases. And here we see scope, again, another way to look at the data. Distribution of cases and interest groups by issue area. You can, again, point to a few I highlighted where you'll have more cases than expected based on those other hypotheses. And we're using network analysis, spatial as well to bring in here. What the punchline is that there is geographic distributions here that wouldn't normally be found by random distribution. So we've gotten a lot of excitement about that. It's also fun to trace over time. You can do some time series plots of what areas are hot. So for example, you probably know the environmental stuff was big in the 70s, right? Railroads, not so much anymore. So we have a lot of fun data that we're playing with, provide really a new perspective on the study of external factors that impact judicial decision-making. Thank you.
Thanks, Jan. All right. Well, I'm going to present today with two of my students. Research in the Human Complexity Lab overlaps in three primary areas. First is theory-driven anthropological research, a thematic focus on human environmental interactions and sustainability, and computational methods. The picture and the figure on the right of this slide show the results from a public goods game that we collected in Belize as part in 2 Kekchi Maya villages. And this was part of my NSF career project. You can see the trend of simulated forest levels for 30 games over 10 rounds as groups of players depleted a shared resource. And the most interesting result from this study highlights the capacity for more sustainable slash and burn agriculture when the game was framed using familiar environmental cues and social norms. This is an example of small data research that we hope to model eventually with Bayesian statistics. The groups shown in black quickly depleted the simulated forest, but the groups shown in blue exhibited a willingness to sanction other players from overusing the resource. Now off to Matt.
So I'm going to tell you a little bit about my thesis, which is actually just one piece of this larger project in which we're trying to answer whether Kekchi Sweden enhance tropical forest ecosystem structure and function through intermediate scale forest disturbances. The workflow I developed analyzes 2 of the spatial data sets. The first is a fragmentation analysis of the automated classification of land use classes. And the second is a principal components analysis of the spectral variation in multispectral raster images to infer forest diversity from remote sensing data. And so part of the big challenge of this thesis was basically figuring out how to put all this together and generate the relevant statistics, which would then summarize different aspects of the landscape. And also another big component of this was the high performance computing aspect, which allowed us to iterate on the project faster.
Hey everyone,
I work in the human complexity lab with Sean and Matt. A common thread in my research is the use of network analysis. So on the left here, I'm showing a figure from a recent paper where we looked at the relationship between subsistence harvest diversity and the patterns of resource exchange in Southwest Alaska. And on the right is an agricultural labor exchange network that shows the influence of church membership on labor reciprocity, something that we're exploring in the complexity lab. So I've interacted with a lot of folks who are interested in networks and social ecological problems. So this inspired me and some other students to form the Social Ecological Networks group, where we meet twice a month to talk about network theory and learn methods together. So I'll drop a link in the chat because this is open to anyone that wants to get involved. Thanks.
Hello, this is Social Network Hierarchy and Residential Substance Abuse Treatment Facilities by Keith Warren. And I should say that Ben Campbell is very much involved with this. It really was his idea. And my title was How Are Hierarchies in Parakeet Flocks and Therapeutic Communities Alike? I do a lot of work on studying mutual aid-based interventions in social work. And particularly, I do a lot of work with studying mutual aid-based interventions in substance abuse. Therapeutic communities are mutual aid-based residential treatment centers. People are supposed to help each other. The view is that the entire community is the method of intervention. The answer as to how parakeet pecking orders and therapeutic communities are alike is that eigenvector centrality describes both. Hobson et al. 2018 showed that eigenvector centrality describes hierarchy in flocks of monk parakeets. The lowest ranking parakeets get pecked by parakeets, who themselves get pecked by higher ranking parakeets. So lower ranking parakeets have a higher eigenvector centrality. They get pecked by parakeets who get pecked. Therapeutic communities require residents to correct each other. Residents, therefore, should tend to have a lower eigenvector centrality at the end of treatment because they should have moved from high eigenvector centrality, the bottom of the correction order, to lower eigenvector centrality, the top of the correction order. And those with lower eigenvector centrality should be more likely to graduate. We've done the study, it's under review. Both hypotheses were mostly confirmed. We tested them in 6 units. TC residents tended to have lower eigenvector centrality later in treatment in all units. Eigenvector centrality was negatively correlated with graduation in 5 of the 6 units. The 6th one was a 16-bed unit. It's not even sure that clear what eigenvector centrality means in a 16-bed unit. Why would anybody care about this? Well, it implies that clinical change is a process that involves the entire social network in the TC, which is what the TC would say. The community is the method. It also involves movement through the network. The deep network matters to recovery, not just the direct connections. Thanks.
Hi, I'm Steve MacEachern, Department of Statistics, and wanted to talk to a little bit today about some of the work that we've been doing, thread of work that's been going on for many, many years about how to do a robust Bayesian analysis in a sense. You know, there's an interesting feature that people within statistics kind of all know, and that is that long ago, people started with the axioms of rational behavior from economics and asked the question, how should one do statistical inference? And the answer that comes out is Bayes. And there's no question about this. I mean, the mathematics is airtight. If you want to use data to make decisions, use Bayes. And yet that's purely formal mathematics. The big question is implementation. And as soon as you move to implementation, you find out that there are a lot of questions. Old school debate about choice of prior distribution. More recently, people think much about the choice of a loss function for making decision. And of course, there's a choice of what you might call the model from a classic perspective, just the likelihood that you're going to write down at the sampling density. They're big things. We have solutions or pieces for all of them. What I'd like you to do is think about a little thought experiment. And the thought experiment is a simple one. Imagine you have n cases, IID cases. You know that k are outliers, bad data. they don't reflect the phenomenon under study, not big residuals. They just don't reflect the phenomenon under study. What would you do for a Bayes analysis? You would discard the data that are irrelevant for your problem at hand. And you would simply use Bayes' theorem based upon the good data. And everybody agrees with this, right? You have garbage data, don't use it. Use the real data, use the good stuff. Once you do that update, then you just move forward with Bayes and you do all the usual stuff. Find posteriors, move to predictive distributions and things like that. And it's simply a sensible thing to do. But here's the neat thing. We don't have to think only about outliers. We can think about any problem and we can mirror this strategy. And we can take and divide our likelihood into two pieces. One piece we're going to consider to be the piece that conveys real information about the problem at hand. That we'll capture with a summary, say T of Y. Oftentimes a good summary is going to be a good estimator, by the way, maybe with robustness properties or something like that. And we'll simply drop the rest of the likelihood. We'll use Bayes' method doing an update based on the summary T of Y rather than the entirety of the data. And what we've found is that this produces much better answers for a lot of problems. For estimation, at times you get a reduction in bias and a reduction in variance, sort of the ultimate goal of everything. For testing, there's just a little figure on the bottom. You can ignore it. Black is full likelihood. The red and the blue curves up at the top are for robust likelihood based on M estimators. The answers are different and are convincingly better in many problems. Thank you.
Hello, my name is Sam Clark. I'm a demographer in the Department of Sociology, and I work on a variety of things that have to do with health and population issues, many of them in Africa. So the first thing I want to talk about today is the burden of disease. We have a project where we're eventually aiming at characterizing the burden of disease as a key population health indicator. This is important, especially for a lot of lower and middle income countries. Globally, roughly 40% of deaths are not registered. Roughly 60% have no cause, which is a gigantic hole in the basic data source to do this kind of work. So we have done a lot of work contributing to the verbal autopsy method for ascertaining cause of death, which uses a short interview with caregivers of someone who's recently died and then infers a cause of death from the responses to those questions. So we've engaged in a bunch of things around this, developing new methods for automated cause assignment, which is basically statistics and machine learning, and working with WHO to develop global standards for it. Moving on, I'm going to talk about mathematical models for age-specific mortality. This is zooming in a little bit more and becoming more specific. Lots of pieces of demography need models for systematically varying quantities by age. We focused on mortality and developed a very parsimonious model for age-specific mortality in single years of age from 0 to 110. We use the SVD decomposition to take a great big empirical data set, summarize it, and then build models that relate the weights in that SVD decomposition to covariates that are interesting in the forecasting and estimating that the UN Population Division does. And then just a couple miscellaneous things that my group and I have worked on over the last year. We've done a lot of work on estimating COVID-19 prevalence in the state of Ohio and developing new statistical approaches to take into account very challenging defective data generated in various ways. I've done a lot of work earlier in my career on data methods themselves, just relational database schemas and processes for collecting and organizing complex longitudinal data in useful ways. And then we've also worked on indirect methods for estimating mortality from summary birth histories and small area estimation of under 5 mortality rates from complex surveys. And I think pretty much done with what I wanted to say. Thank you.
All right. Hello, everyone. I'm Hyunwoo Park from Fisher College Business and core faculty at TDAI. My research theme is to apply network science and data analytics to business phenomenon and organizational relationship like supply chains. today I chose to show you some of my work that are most relevant to the TDAI community, I think. So I will demo a few interactive systems I built for research projects. So what you're seeing is an interactive network visualization system that analyzes venture startup business ecosystem. So the whole network data set contains like tens of thousands of nodes. So it will be impractical to have them all portrayed at once. So the system allows you to kind of start from the nodes that interest you, and then you can kind of expand from those nodes stepwise fashion, so that it can highlight. So in this network, the edges are basically a similarity between two different startup companies. So by allowing users to kind of explore the network from certain nodes of interest, it can kind of quickly generate the insight of which nodes are, for example, in this case, which startup companies are similar to one another using some basic network analysis, visual analytics techniques. I feel, Dev, can you kind of go to the next slide? Yeah. So when we tested this system to some of the executives, they really wanted to use our system with their own data. But the first challenge we actually got was to train them to how to create this network data in Excel. And that was not as transparent because network data involves kind of two tables, and people are familiar with this kind of rectangular table format. So it was kind of first hurdle to go over, to educate them that these two sheets come together to form a network data. So the next kind of research project we kind of tackled on was to build. Dev, can you move to that? Yeah, okay, that's good. So the next project we tried was that instead of kind of having a tool for a network data itself, why don't we kind of try to build something like Google like thing for network visualization tool. So all you need to do is to put in some natural language query like autonomous car in this case, and then it generates the network on the fly, and also it prunes the edges a little bit on the fly to alleviate the hairable-ish clutters. And then it then kind of generates basically this topic networks for a given query. So yeah, so this is kind of an interactive system for creating and analyzing network data. And for example, here you can find Uber, and you can find the article that links to that kind of gave rise to this network structure on the right-hand side, and you can kind of go back and forth to refer to those articles, etc. So you can discover some new themes like self-driving tractor, which I wasn't aware when I typed in autonomous car as my keyword. So yeah, I'll stop here. So Dev, can you just move to the next slide? I feel like it is waiting until the movie ends.
Hey guys. Yeah, so this is a project that I've been working on with Bear and also with several other people, broadly from a political science and specifically international relations background. So we're sort of interested in this like sort of broad question of human cooperation and what makes it both emergent and stable, right? And there's this sort of common mechanism that you see where sanctioning and sort of costly punishment encourages cooperation in a stable way. And from a political science perspective, we saw a piece missing from this, which is that most of this literature thinks of sanctioning as something that's done by peers, something horizontal. Whereas sort of we're sort of looking at getting into the aspect of this more about governance, right? So we think of the creation of a state or an international organization to govern cooperation as a sort of fundamentally sort of different mechanism that underwrites cooperation via the mechanism of costly sanctioning. And specifically, we think that one thing that's important to the development of these kinds of governance organizations and sanctioning bodies is intergroup conflict, right? Which is another thing that's sort of a theme in the sort of general like interpersonal cooperation literature. So what we did to develop our hypotheses initially is we built a pretty simple, just like toy agent-based model with a few, which gives us a few results. So the first is if you allow agents in multi-group public goods games to incrementally develop hierarchs will enhance cooperation, but only in very, very specific parametric cases without conflict. What introducing stochastic conflict between actors does, where the outcomes of the conflicts is endogenous to the results of the group's public goods game, is it basically expands the parameter space in which you would expect to find cooperation via the mechanism of the bargaining to create costly sanctioning hierarchs, right? And what we found that's sort of most surprising is that when you introduce limited memories, right, when you can forget conflicts, what you end up with, for a reason that's more complicated to go into in this lightning talk, is cooperation actually becomes more universal and more stable as a result of conflict, right? So in order to sort of validate some of these hypotheses that we have, there's a variety of things that seem to fit this kind of intuition, both in terms of sort of the history of state building and international organization building, but also in sort of natural sciences, with some sort of primate species. So we're looking at various sort of observational means to validate some of the hypotheses that come out of the model. And also we're sort of in the very early stages of designing survey experiments to try to validate some of this, to sort of like get people in the lab and sort of recreate the kind of model that we built to sort of give it sort of more firm micro foundations. I guess that's about time, I think. So there we go, perfect.
Hello everyone. My name is Quinn. I am a second-year PhD student in communication. Today, I will be presenting two research ideas that I am developing in progress that are related to using computational tools to understand communication questions. So the first research idea, which will be the major focus of my sharing, and it's actually developed in Baer's causal mechanism class, is related to how misinformation, and in particular, political misperceptions, thread in our social networks. To give you some background, the literature on political misinformation has mostly focused on social psychological processes and explanations related to the political environment and the information environment. But there is another line of research suggesting that misinformation and misperception have a social dimension. And in particular, our adoption of misinformation is related to how we get exposed to these ideas through other people in our network. So my motivating question is how do people come to adopt these political misperceptions and correct political beliefs? What is the role of social networks in this process? To understand this question, I use complex contagion model as a theoretical model to explain the spread or the adoption of social beliefs and behaviors in situations where people don't immediately adopt a belief if they only get exposed to it for once. Instead, people require multiple exposures from different individuals in their network to adopt a belief. In addition to the complex contagion model, I consider the role of political identity in both shaping the extent to which we are segregated from our outgroup and the extent to which we are convinced or persuaded by other people in our network. So my major approach is to use an agent-based modeling approach to explore what macro-level patterns emerge as a result of different parameters and come up with an empirical research design to test this model. And above and beyond misinformation and networks, I'm also interested in studying how people navigate through the online news landscape. For instance, do people, in particular Democrats and Republicans, segregate themselves into different online media diets? Do we observe a polarized news consumption patterns among individuals? My research uses web browsing data from individuals to understand whether and when people of different political leanings selectively expose themselves to ideologically congruent news sites, use network analytic tools such as community detection and latent space model. And I welcome any comments and feedback on these rough research ideas. Thanks.
Excellent. Well, thank you, everybody. That was excellent. Remarkably smooth, a highly trained group of scholars here, clearly. Thank you, everybody, for putting the time and patience into putting those talks together. I know it's very hard to do quickly. So with that, I think we have some time here to, yeah, a round of applause to everybody, first of all. I think we have a little bit of time for a discussion, so I can just open the floor to questions. There's been a pretty active chat, like I said, so if we don't get to everybody's question, we can always follow up by email. But the floor is open. Does anybody have a question?
I think I've been putting mine in the chat.
Yeah, please, Donna, go ahead.
Keep up with everybody, but actually the last and the first talk seems like there is a nice, going back to the beginning connection, because Chen, about misinformation in networks, and Silvia testing about what people actually respond to and how people consume information or misinformation, right? And how that's particularly in online content and in online, and what role the network structure plays in that consumption.
Yeah, I can maybe pick it up for a second there. I totally agree. The last and the first might have that clear connection, and I think they're also complementing each other. You can take that network approach and look at like trace data, digital data that you can download and scrape, and combine it with a different perspective. Like my work often looks at it from an experimental perspective, but still observes people as they actually select those messages, and with large samples ideally. So it's kind of a complementing approach, because oftentimes you can't clean up all the confounding factors out in the field, but that's where I come in. But still, you want to have then observe on a big scale how those what the contagion is, so to speak. Yeah.
Chen, the network approaches are typically more of observational, right? So they don't allow for a lot of manipulation experiments. So I'm wondering if Silvia's approaches can be, like, what hypothesis one can test using Silvia's approach that come out of the network-based observational approaches analysis.
Yeah, that is actually a great question, and I haven't thought about it. And the network approach that I'm using is mostly testing at the aggregate level, at the media system level. How do liberals tend to consume conservative news sites and avoid liberal news sites, and vice versa. And actually, the work that Silvia has done in the selective exposure space has shown that this is not really the case, and there are specific boundary conditions to that. And I definitely agree that using the observational data, I am not able to separate out different perhaps mechanisms and confounding variables. And I am definitely looking forward to build on what I have through the observational data and text specific mechanisms and variables using an experimental approach or other approach to separate out these causal mechanisms and variables.
One thing or concept comes to my mind, at least, that was evident in a lot of the talks. I think several speakers touched on intergroup tension or conflict, be it local groups, geographic regions, or racial ethnicity groups. So a variety of talks touched on that. And that can be one of the factors that lead people to select a source or a message as it aligns with their identity, in whatever way you think about these group definitions. And I think that might be interesting to a lot of the people in the room to model these trajectories. So maybe that could be an overarching thread that a lot of people are interested in.
Excellent. Are there other questions? Floor is open.
I'll continue then. So there's seems to be a lot of different projects that are related to network analysis, or either designing approaches for or consuming the outcomes of network analysis from different perspectives. And I know it's a strength. What I've seen is not a lot of dynamic. Networks change over time, right? And one of the strengths of networks is seeing sort of how the changes in the network connect to other factors, whether it's the movement in some latent space like political opinion, or the changes in the therapeutic communities, or the alignment of the Hyunwoo's, the alignment of different partnerships, economic and business partnerships. So any comments on sort of how the work that you're doing in different projects? To me, it's interesting how the dynamic aspects of it, and have you looked at it? And
Anya, I can jump in. You know, we had a little thread going in the chat about the Milpa game, and it certainly didn't show in the analysis I presented. But one of the ideas that we have, I've worked on this with Shane, or Shane's worked on this more directly. He's done the data analysis for it, actually, is to look at how motifs of cooperation evolve over the course of specific individual games, because each player is essentially playing chess with all the other players in each of those games, and it's really. It's only a 10-round game, unfortunately, so it's not, you know, we don't have long-term evolution of cooperation, but that's, you know, that's something we really want to try to see if we can tease out of that experimental data set to figure out, you know, how little subgroups might be, subgroups of cooperators are emerging throughout the course of certain games, and whether those lead to the more sustainable outcomes for the forest.
Yeah, I can add that we actually care a lot about dynamics, because we're trying to figure out how you construct networks in these programs and foster networks in these programs that lead to recovery. And that's fundamentally a dynamic question.
It's also a mechanism design question, right? It's about how do you design that game of cooperation so that the network outcomes are the ones that you want.
Yeah, no, exactly. We're working on it. I can send you some of what we've done. We've done a lot of dynamic network analysis.
So I can jump in as well. The model that David described, I mean, you know, again, it's pretty fundamentally dynamic. It's, you know, starting at scratch with a public goods game and sort of seeing, you know, where the availability of hierarchy and conflict among hierarchs gets you as the game evolves over time. And I think one of the really interesting directions in which we want to take it is exploring whether those dynamics are similar across cultures. Because there's been, I remember we came across a really interesting study about public goods games that demonstrated that American subjects and Chinese subjects react very differently to sanctioning. You know, the Americans will contribute and the Chinese will tell you to go take a hike. Is in general. So, you know, one of the things that we want to be very sensitive to is the possibility of, you know, globally unrepresentative outcomes of how those dynamics work.
You know, perhaps a little bit of a different perspective, right? Mine is much more on the statistics side and less on the social sciences that you all have. But you know, within the world of statistics, you know, time series models are particularly hard, and I'm sure Janet could tell us all about this much more clearly. It's very hard to get the model right, because you've got to get not only the right marginals but the right dynamics through time, and it's just exceptionally hard. when you move from individual data series to networks evolving through time, unbelievably difficult problem to get right. And, you know, the notions of individual differences, you know, you're not going to capture them by saying, well, we'll add a normal random effect, right? I mean, it's so much more complicated than that. And Bear just touched on it, right? I mean, it's not just cultural, but within cultures, there are individual differences too, I'm certain. And, you know, the real question is how you can develop robust inferential methods that really target the quantities that are of most interest to you, that are robust to the deficiencies that almost have to be present in your model, simply because it's too hard a modeling situation to get right. And I think that is really open territory. There's a little bit that people know about that, but I mean, there are going to be huge fundamental papers and work that's done now. I think that'll really set the tone for, you know, the next decades, because networks are never going to disappear. Networks, dynamic networks, I mean, once they're here forever. It's simply real data, and we collect the data and track things now in wonderful ways. I think it's huge, huge territory for just fundamental work, and now's the time to do it.
I'm going to throw a controversial thing. Networks don't exist. Networks are a very convenient model, right, that we're using to describe relationships and data, but nobody's walking around, right, with a stick saying, there's a connection right here, there we go. And even as we define networks, there's a lot of parameterization that goes into that definition. And on the same set of individuals, you might have different networks that are firing under different conditions in different contexts. And I think that the first question is, what is the right network for the question that we're trying to answer, right? And how do we do model selection on networks? And then how do we, like, what do we mean by where network is the model, right? So how do we do this model selection? How do we do it in the dynamic sense? And how do we do comparison of dynamic models? And this, particularly when you're talking about multivariate, highly nonlinear dependent collection of time series, which is what dynamic networks are essentially. And some of the recent approaches are bringing together sort of this the data-driven and the statistical approaches together, where you're asking what is the most sort of, in correlational sense, predictive model, which is network. What is the most predictive network that answers this particular question, or what is the model that I can learn, whether it's network or not, machine learning models from data, and how are they constrained by the statistical Bayesian or other kinds of models, and where do the two meet? Because that allows you to both answer the hypothesis kind of questions and hypothesis testing versus the forecast, they take into account all the data relationships, which are typically too complex for statistical models. And I don't know if anything that I just said makes any sense.
It does. It brings to mind, well, former student of yours, Aaron Clauset, published a piece, I think last year, on stacked networks for prediction. And it was more about about prediction, not hypothesis testing. But I thought it was a really interesting take on like what you do when you're looking at all of these different networks and you want to try to figure out, how to make sense of their interaction. I think it was in, I forget which journal it was in, but I can dig it up.
All right.
We can have side conversations in this one, can we? Like really well.
Yeah, there's a pretty extensive chat transcript that we have. We'll definitely download that, save it, and maybe format it a little bit and send it back out to everybody who joined us today. We've got 2 minutes left if there are other questions that are burning.
Yeah, this is where we all break for lunch and pair off and talk more about our projects.
Yeah, exactly. We're sort of, should I start something new with 90 seconds left, or should we take our minute and a half and get an early start on lunch? Well, I think that this was really enlightening and interesting and exciting, just to see the breadth of work that's going on, especially the overlaps of work too. I mean, there's lots of cross currents here. I would say we should start a community of practice, but we have one. Here we are, and that's why we're all here. So I think it's sort of a validation. I think that we're heading in the right direction, and I'm looking forward to trying to develop some programs with Bear as the leaders of the COP to kind of further magnify, highlight, and provide structures and venues to enhance them over time. So with that, I guess I will thank everybody and close things out, and look forward to seeing everybody in the RSS next year. We'll follow up via email.
Thank you.
One sec. So we're and the leadership team just got the message of we're starting to think about full forum. So start to think about full forum and presenting the work that's been here, or other additional and particularly engaging students, postdocs in both presenting and planning and helping shape the full forum, because that's our biggest community event. And you are a community, clearly there's a lot of overlap. So with that, we're looking forward to hearing your thoughts, your ideas, and helping shape the full forum, and then finally actually showing up there. So yes, thank you all.